Welcome, and thank you for joining us for today's webinar, Next Gen Manufacturing, Trends and Predictions for 2024. My name is Megan, and I'm the moderator today. The agenda today will focus on revisiting our predictions for 2023. Did we meet those predictions? Erik and Mason will take a deep dive into that today. And then we'll take a deeper dive into our predictions for 2024. Emerging trends that are here to stay. And then lastly, of course, how to navigate these latest shifts. And now I'm really excited to introduce our speakers. Mason Glidden leads product and engineering teams here at Tulip. He's been at Tulip for more than 9 years, helping grow a tiny 5-person startup to a 300-plus person company it is today. In his role, he's responsible for Tulip's cloud product and edge services, as well as his technical operations, QA, and the support behind it. Erik Mirandette, the Chief Business Officer here at Tulip. His role includes management of Tulip's go-to-market strategy, including direct and indirect sales, as well as operationally managing Tulip's customer success, customer support, and customer services organizations. Awesome. And take it away, team.
Well, first of all, Megan, thanks for having us. It's great to be here today and looking forward to getting into the topics with you.
Yeah, for sure.
I think we're going to kick off with a quick poll. The first question we have for everybody is, what are some of the blockers to achieving your top initiatives in 2024? I'm not going to go through all the options here, but let's take a minute or two and just hear from the crowd. What are you guys thinking about this year?
It seems like one of the top blockers, there's a little bit of a tie. Increasing manufacturing agility, improving employee hiring and training and retainment, and reducing manufacturing costs. It seems like agility seems to be the top blocker.
Yeah, we're going to talk a little bit about the need for agility in the context of manufacturing and some of the macro trends that are still affecting manufacturing operations, particularly the challenging labor environment that's out there. So thanks everybody for sharing your thoughts there, and let's go ahead and kick things off. So the first thing we want to do before we get into this year's prediction is talk a little bit about last year's prediction. You know, it's easy to say what we think is going to happen, but we do believe in keeping ourselves accountable here. So what did we say last year, and how did we do? So last year we said was the year of the triple squeeze, characterized by 3 major macro trends. The first was major inflation. So I think last year we saw a peak of like 9.3% year over year cost increase in the CPI index, just supply chain disruptions and labor shortages. Of these things, really the first 2, so inflation and supply chain disruptions, have mostly settled out. Looking ahead to 2024, the biggest factor that we see continuing to influence manufacturing is this constrained labor environment that we're seeing. You know, we've got a lot of investment domestically here within the U.S., a lot of nearshoring, reshoring, a lot of domestic investment in terms of capital availability for manufacturing operations domestically. The constraining factor continues to be a qualified and available workforce to come in and take these jobs on. And as we're going to see through the course of our conversation today, there's no silver bullet to this. It's not like AI is going to solve this problem for you. It can help, but it doesn't replace the need for human beings on the shop floor.
You know, one of the other core predictions we made going into this year was talking around the fundamental change in software, the move from on-prem based systems into the cloud. And I think we've really passed this inflection point. There's no going back. The way we think about manufacturing systems has changed forever. To break it down a little bit, one, we're seeing a huge move to the cloud, not only for SaaS-based systems, but for people hosting their own software as well. From a cost and reliability perspective, sort of the tide has turned. Cloud is the new de facto for all of these applications when applicable. I'm going to add a little asterisk here. Not all systems are qualified to move to the cloud. There are certainly shop floor systems like SCADA and things like that need to remain local to your factory floor. But for the higher order business systems, everything's moving to the cloud. We're continuing to see a move as well towards SaaS as the standard and sort of default here. All of this is driven by the need to adapt to complexity, right? With the triple squeeze, things are changing all the time. The challenges today are different than the challenges a year ago and are different than a challenge in the next year. And a lot of this cloud migration is being driven by the need to continually adapt to changing complexity and needs. Where we're continuing to see, as we look forward, there's a continued step up in workloads migrated to the cloud. We have a quote from Gartner here that by 2027, over the next 3 years, it'll move up from 45 to 65% of application workloads ready for the cloud. There's an interesting sort of mental model and sort of inflection point that we're seeing here. Over time, the value of moving to the cloud is increased and increased, right? They're more stable, there's more there, you can do more with them. And at the same time, risk is lowering. Now, what do we mean by risk, right? One of the primary disadvantages of moving to the cloud is that internet connectivity becomes as fundamental of a need to run your operations as power, right? More and more, the internet goes down, your factory can't run anymore. However, internet infrastructure is continually improving year over year. In the past couple of years, we've also seen the rise of things like Starlink and 5G that are alternative means for internet connectivity to provide redundant backups that are continuing to lower the risk. So you have this interesting model where the value is going up and the risk is decreasing. But when evaluating choices, people are often looking back 5, 6, 7 years at the mental model that they had back in, say, 2015, right? So people's mental model is not always caught up with the current state of technology in terms of the risk reward benefit across here.
Yeah, and if I could just add to this, I mean, this is something we see quite a bit. A lot of times folks, when they're starting to think about what types of solutions do they want to implement to help run their operations, will ask about what happens if the internet goes down. And what we see, first of all, you're looking at 5 to 6 nines of uptime for these services. So extremely reliable, driven by increased investment in fiber optics and decentralized architectures for making this network available, as well as some of the redundant mechanisms that are increasingly being put into place. Mason mentioned 5G. Starlink is out there for and will be moving its way, we would anticipate, into the business context here in the coming months and certainly years. So there's this bias towards thinking about what was reality 5 years ago, 10 years ago, and then making decisions today based on that reality.
Exactly.
Which doesn't match necessarily the moment in time that we're in. And then the other piece of this is, as one of the things we're going to talk a lot today about is this open architecture as being a prerequisite for doing business in 2024 and beyond. There's the days of having one stack, one system, one product that solves all of your problems they're long gone. This is an artifact of the past, and open architectures are here to stay. What the consequences of that is that the more you can connect these systems together, and the more information that can flow between these systems. At the end of the day, why is that so important? It gives the appropriate context to the person who needs it to make better decisions real time right now. And oftentimes, the dependency for what information you need to make that decision lives across different systems. And so, again, this is just another factor driving increased value in having these sort of open systems that are necessarily based on cloud architectures. So, this is something we see quite a bit, and I think it's worth spending a moment sort of reflecting on this.
In the chat, Bob just posted a really interesting readout of the security implications of moving to the cloud. Thanks for posting, Bob. I haven't read it myself, but definitely want to read it afterwards. And I think it's a really interesting point, right? There are certainly some workloads that, from a security perspective, are never going to move to the cloud, right? Something classified, it's always going to be an on-prem system forever, right? When you have that need to utmost security requirements, that's the reality, right? You also lose a lot of the benefits of those. Also seeing a world where companies like AWS and Microsoft are realistically going to be better at security than outsource some of those security requirements to them in order to not have to think about what does physical security for our data look like. Yeah,
you end up in a situation who's IT, and who's security folks do you trust more, AWS or your own? And tell you what, AWS is pretty good, So now we want to talk about some of the predictions. We covered a couple of the predictions we made last year and how we've seen this how we've seen this pan out. Now we want to talk a little bit more about what are the key driving trends that we see coming in 2024. The first thing that I want to really call out here is that we think that MES is going to become an increasingly less relevant category. We'll get into a little bit more what we mean by that, but you're seeing this term MES sort of evolve. It's been a term that's been fairly static over the last 20, 30 years. And I think the last few, 2, 3, 4 years in the Magic Quadrant, you've seen quite a bit of interesting things happening there. We think this trend is going to continue and want to double click what we mean specifically by that.
We're also seeing a move towards open architectures that are going to power the next layer of infrastructure. This space has become too big and too complex for any one solution or company to go it alone. Building open ecosystems is going to become a core requirement of how people approach these problems. Obviously, in the past year, in 2023, generative AI was the hot buzzword. We see that actually starting to rubber meets the road a little bit this year and provide real concrete value there. And that's actually going to tie into our fourth one here of changing the ways that manufacturers add context and information to their data and the needs of data collection changing a little bit in the coming year.
All right, and the last thing here is one of the trends we're seeing, and this is related to the constrained labor force that we're operating within, but you have trained engineers coming out of these programs looking for, they've taken DiffEq and linear algebra, and they've got a little bit of coding under their belts, and they're looking at professional opportunities out there, and frankly, not a lot of them see a future in manufacturing, and that's something that needs to change. And what this boils down to fundamentally, and at least if you ask me, and one of the things I hear quite a bit from folks coming from industry applying to jobs at Tulip, and this happens all the time, this is a quote that they'll say. They say, like, look, I'm a trained engineer. I want to be an engineer. And a lot of the tasks that are necessary and the things that are necessary to keep manufacturing operations running smoothly don't leverage the full potential and skill sets that these folks are bringing into the job for, into the labor force, and bring with them to their first job, second job. So in order to attract and retain these folks, we need to give them the right tools, and we need to leverage the potential that they actually bring in the most effective way possible. And there's a lot of interesting ways that we can do that we're seeing sort of proliferate throughout industry here. Okay, so let's talk a little bit about MES. I said MES is going to become an increasingly less relevant category. What do I mean by that? Well, you ask me, I don't think MES has ever been a thing. A bit of a controversial claim here, but if you look at what MES actually is, it doesn't describe a fixed product with fixed capabilities that you say this one is like the other. For example, if I need a word processor, or if I need to make a slide deck, PowerPoint and Google Slides, they're basically the same. I could use Word, I could use Google Docs. I know what I'm going to get, basically the same set of capabilities. That is not true with MES. MES describes this constellation of challenges that exist across the manufacturing operation. And depending on, like all of these problems are sort of lumped together, those problems are the MES surface area. Now, the MES product...
To jump in here for a second, Eric, I remember years ago reading a book. It was like the definitive guide to MES or something like that. It was some textbook style thing, and it spent literally the first third of this book trying to define what MES was. I think this is inherent in the problem space, right? Manufacturers are so diverse and so different, and their corresponding needs are oftentimes so different and diverse that it's impossible to have a one size fits all. Like, yes, here's your word processor for manufacturing style.
Yeah, and you almost have to. There was a really interesting post the other day by Industry 4.0 Solutions, a Walker Reynolds post that that brought attention to this issue. But the fact of the matter is, every shop floor is different. If you have two products that need to be built across the street from one another, they're the exact same product. You're going to build it, with the same tools, the same labor force. The process by which you would build these products would diverge in hour one of building this facility and building out this plan. So it's not like you can copy and paste these solutions, in its mature state, in its fully composed state. You can't copy and paste MES from one facility into the next facility. It has this intrinsic need for customization. And furthermore, we believe that the solution, the product should conform to the needs of the operation, not the other way around. You should not be changing your operation to accommodate shortcomings of the product itself. And so that's what we mean when we say MES itself is going to be a less relevant category. When you combine this with our next topic here about open architectures, what we envision and what we see happening more and more is this open architecture where you can take best of breed solutions to solve very specific problems, and then that they work seamlessly with one another, sharing data back and forth. And that creates a very, on the one hand, it's a build motion that needs to take place. On the other hand, I think more broadly, you're going to see MES start to kind of wane, and you're going to see this category of frontline operations platform become much more mainstream in the coming year. Gartner said last year that by 2025, at least 25% of manufacturing applications are going to be built on composable technology, and this is up from less than 2%. So this really speaks to the need to build, right? So starting with these packaged business capabilities, these units of functionality, the digital Legos for operations, if you will. Employ the ones that make sense, combine them in ways that make sense for your operations. And this is like a major shift that's taking place across the MES landscape right now.
Agreed. And I think there's actually an interesting parallel here between how you build a composable set of applications and our next prediction around ecosystems. One of the things we put here is digital architectures would build on open ecosystems. And before we get into here, let's quickly define open ecosystems, right? An open ecosystem means a set of common technologies, APIs, interfaces for all of these systems to be able to interact and act together. One form of this, for example, could be an MQTT-based open architecture that allows all of your systems to talk together and integrate. Generally, the previous version of you're going to go to insert big company here and get everything you ever need from that one company, and they're going to be your full end-to-end solution. Those days are over. It's not possible to solve all of the problems in manufacturing operations like that anymore. You're starting to see more multiple interconnected solutions that can solve specific pieces of the puzzle. Speaking to Erik's point about the constellation of needs and solutions coming together, integrated together into one comprehensive solution for you. To double click on that, in the previous sort of walled garden approach, you're going to have limited choice, there's limited flexibility, and this tends to lead towards a top-down approach, right? When you're picking one system, one overall thing, you have to enforce it top-down, versus on an open ecosystem, you can balance that top-down with a bottoms-up approach and enable more democratization of your software and your technology here. Lets you pick different best-in-class solutions and find ways to combine them together. And join all of those different features into your unique constellation of solutions. We're starting to see vendors work more together, build on top of open specifications, and come together into one cohesive solution. There was actually a great quote here from Blake, the chairman and CEO of Rockwell, who said, it's just plain arrogant to think that one company can do it all. And I think this really emphasizes synthesizes a lot of what we're seeing in the market towards the next year. Everyone's starting to realize how do we play together is a key component of really solving and cracking this problem across the whole industry. Next up, we have generative AI. So for those of you that haven't been living under a rock, obviously this is probably not a surprise that it's showing up here. It's been the hot thing over the past year, but there's been a lot of hype. Right, there's been a lot of ChatGPT is coming for everything. It's going to take over every job, all of this stuff, and I think we're going to see a little bit more of a balanced perspective as we go into this coming year, and a couple discrete use cases where we think it's actually going to help frontline operations very specifically. At a high level, there are three areas where we see generative AI specifically influencing manufacturing operations. First up, we have development, right? When citizen developer, when you're building these composable applications, we see generative AI techniques really helping to pull all of this together and lower the barrier of entry to getting started with some of these systems. Second up, we have data. There is, and we'll talk about this more in the next one, so I won't go too deep into it here. Some of these new generative AI techniques open up entirely new ways of working with large forms of data. There's obviously a plethora of techniques that have existed mostly on numerical data. The new generative tools are really key for understanding more high-level semantic text-based data, which is really so prevalent in frontline operations. And then finally, we think it's really going to recurse down as well to operators themselves, and to giving better tools to the people on the front line in order to actually help them do their jobs better, whether that's understanding the manual or figuring out how to solve a set of quality defects. It's going to finally recurse down to that last layer there. As we go forward, there are a couple stats we've called out to sort of support our claim here. First up, we see the vast majority of companies starting to think about how to implement AI somewhere in their production. We're seeing pretty dramatic increases in productivity due to those adoptions. And then a good chunk are already getting started. So we're still seeing about 30-ish% here beginning their journey next year versus the 2/3 that have already started. But we think this will be a real change and see actual benefit from all of the hype that we went through this past year.
Yeah, and a key point that I just want to emphasize here is I think these generative AI capabilities, as Mason is saying, have the power to dramatically impact the efficiency and effectiveness of the workforce you have. That said, it doesn't solve the labor problem. You know, you can do more, you can go further, but it doesn't mean that, you know, these tools aren't going to be making decisions for you, solving problems for you. They're not going to be doing the thinking for you. They're going to provide you a distillation of the necessary context that you need at the time and place to make a better decision faster. But at the end of the day, ultimate decision making is going to stay in the hands of the people responsible for these operations, and we don't see that changing.
Totally agree. I think all of the hype around like ChatGPT is coming for your jobs is way overblown. It is not capable of doing that. It is capable. It's why you're seeing all these tools called Copilot, right? It is not capable of being a replacement. It's capable of being an assistant, helping remove some of the drudgery or do your job better, faster, etc. So let's double click on where that changes things for data specifically, as well as, I mean, just the whole data silo, data lake, all of that in general. So first of all, the new tools like ChatGPT are really great at understanding what I'm going to call human data, as opposed to, say, machine data, like a stream of data coming from a sensor or a mill or something like that. These tools are great at understanding text, no matter the language, no matter the context. That is their sort of key motion and key use. And so we're seeing previously unusable forms of data, such as, say, collections of defect reports or 5S audits that go in deep on like why this thing is broken, right? Those sources of data previously required someone to go through and read thousands and thousands and thousands of pages of text in order to synthesize the high points coming from it. Now, this is a super key use case of the new AI tools, and we're already starting to see it change the way that our customers are collecting data and the way that they think about their data, because previously this was all just a black box for them.
Now, that said, there was this idea 5 years ago, 10 years ago, you know, and it still persists in pockets that I see where, you know, data is the new oil. It doesn't matter. Just map the PLC tags. We're going to get a bunch of ones and zeros, a bunch of floats in some database somewhere. And like AI is going to come solve this problem for you later down the road. You don't know what it means. Nobody knows what it means, but store it somewhere in your data lake because, you know, down the road, there's a massive value to be had in unleashing some AI agent on this data. And that is absolutely not the case, and it's not going to be the case. So while AI is giving you new tools to solve this, the context of that data is critically important. And so this is kind of how I love South Park. I also have a mission of having one cheeky meme in every webinar that I do. So this is my quota for this webinar. There may be more. You'll have to stick around and find out. But like this is when you think about people and the mindset here, it's like, all right, what are we going to do? How are we going to solve our problems? It's like, well, first you got to capture all the data. Second, we're going to figure that part out. But we know step three is profit, you know, and it's just so crazy, right? Like, here's what this means. Like, first, we've got, you know, this is the whole classic drip, right? Data rich, information poor. You've got all of this data. What does it mean? Nobody knows. But the point here is that you have the ability with these cloud native tools and these these frontline these frontline operation platforms like Tulip to capture data at a very specific point in time where, this combines both automated data. So the information coming off of just sensors and devices and machines, capturing that data, sure, but then overlaying human context in this as well. Like, here was the result. Was it good? Was it bad? Was it above or below expectations? Like, did you do something as a result of that? And storing this information, and it's the combination of having this data with that contextual relevance. You combine that, and you've got several hundred thousand entries in this table. Great, but it's contextualized, it's reliable. Great, unleash AI on that, and it will be able to provide you with some really interesting insights and capabilities into that data. So this is the key concept, and I think fundamental to how our understanding of how we interact and make decisions based on data in the context of a manufacturing operation continue to evolve. And I say manufacturing, but obviously this extends into the regulated industries as well, medical device and pharma. So manufacturing, I don't mean to be exclusive with that definition, but it's people who are making physical things. Now, this brings me to the last point. I recently hired somebody out of industry, and she joined our. She's going through the interview process, and I'm talking with her, and I said, "Well, why do you want to? You have an interesting job. Why do you want to come to Tulip?" And what she said, this is her quote. She said, "I'm an engineer, and I want to be an engineer again." And she described the situation where she was, she showed up at work. And she walked around, and she was basically her job for the day was to track down all WIP inventory. And so she literally walked through the facility and counted piles of half-finished inventory, and then went on a spreadsheet and said, okay, here's where it is, here's where it's going next. And this is a fairly common activity. In this case, it happens to come from one specific person that I talked with. That's her name's Beth. She runs community. Say hi to her. But I hear this time and time again. And so the point here is there are manufacturing operations is one of the most complex and dynamic environments under the sun. And it is physical, and it creates real products with real people. And it is such a fascinating set of problems that need to be solved all the time. And the problem is we have the people coming out of our universities and coming out of our trade schools that have the necessary skill sets to be able to solve these problems. But the jobs oftentimes that they're being asked to do are necessary. We need to know where the inventory is, and this is a common problem, but it's not sufficient to capture to attract them, to retain them, to capture their interest, right? And so I think when we look at this from Tulip's perspective, we see an opportunity. We see untapped potential many times, and it's if you give these people the right tool, you're unlocking new levels. If Gilad Langer, he talks a lot about order of magnitude productivity gains, and how do you achieve those things? Tulip in of itself is a tool. In the same way that a hammer can't build a house, Tulip itself isn't going to solve these problems for you. But if you combine these tools with the people who are in these, coming out of universities and already in the workplace, that's where you start to see these order of magnitude productivity improvements. And this is just some of the examples of the kinds of questions that that we see our frontline engineers running down. Why is my tray empty? Where's my inventory? I've got to enter all these jobs into the ERP. The new class of tools built on this open architecture that are cloud native. You have the ability to build automations and build workflows that will do all of this stuff for you. What that does is it frees capacity for your engineers to really dig into and start solving the hard problems that only they can solve. And that's fundamental to how we view the world here at Tulip. Well, one more statistic just to reinforce that this problem isn't going away. We mentioned that the generative AI capabilities will help, but not solve this problem for you. In the same way, if you look at this is some research that came out of Deloitte. When you look at the number of open jobs, and every day there's headlines that speak to the fact that we're building a new chips facility in Arizona, but there's not enough people to take the jobs, and so how are we going to solve this problem? But this is kind of at an aggregate macro level across all the United. This is U.S. centric, but they're expected to be a 4 million job shortfall, but between now and 2030, as you have the baby boomers retiring, these high-skilled workers leaving the workforce, and manufacturing is still struggling to attract, the next generation. So.
And I think that, to the AI point, a lot of these tools are really great at helping eliminate tribal knowledge, right? If you start collecting info, reports, things like that, previously that collection of text might have been a black box for you. Now you have these new tools to start to introspect and try to take some of that and actually operate on it when your new employees come on.
And the other thing that we're seeing is there's this transition, and this is really, I think, has been further accentuated in the last year or two, as you've seen what, for those who follow the investor community, particularly in the tech space, there's this term that gets thrown around a lot. It's called ZIRP. ZIRP is dead, you'll hear, and ZIRP is zero interest rate policy. So there's been this over the last 10 years, 15 years, really 10 years, a lot of really cheap capital, which leads to, lots of startups, lots of tech investment. Times were good. This is done. The feds have increased rates. You're seeing a great extinction event, they're calling it, for a lot of these like this. Think about the scooter companies. These companies they were startups, they were hot, but their core business model was contingent upon capital being cheap and growth at all costs. The macro environment has changed. What that's doing is making that as a less. It's like that's not where the highest tech opportunities are. What you're seeing is a shift back into manufacturing. So if you think about like SpaceX and Tesla, these are the companies more than any other that are really kind of pushing the envelope in terms of innovation. And so I think that manufacturing has an incredible opportunity, and we're on the verge of a renaissance of manufacturing. In the U.S., again, this is a bit of a U.S.-centric perspective, but also applicable certainly to Western Europe. Now we're going to talk a little bit about, great, so here are the predictions. What should you do, or what are some suggestions we have to how to navigate these predictions? The first is shifting to this composable approach. It's really important. We talked. I think we've laid the reasons for why this is important. I want to just briefly share with you what this actually looks like. Now, no two operations are the same. We covered that. That's not to say that there's not patterns. In the same way that history doesn't repeat itself, but it sure rhymes. Look, people want process visibility. They want work order tracking. They want to understand the overall productive utilization of their assets, both humans and machines. They want to understand. They need to guide complex assembly operations. They need to track defects. They need to reconcile all of this with the ERP, and they need to capture the information off the machines and the sensors and devices. And you don't need to be so creative. You don't need to create this stuff from scratch. There are patterns and there are components that you can take from, within the context of a global enterprise. If it's working in one place, great, capture it and disseminate this where it's relevant. Now, how these components get combined is where you get into workflows are a little bit different. Routing is a little bit different in this facility, and so you don't want to have this monolithic, rigid system being prescriptive about all of these things. That said, you want the base capabilities, and so this is fundamentally what adopting a composable architecture looks like. And how do you do it? Well, you use you either if you have the people who you're worried about retaining right now, you say, hey, I've got a real engineering job for you to solve some hard complex data-driven problems, and give them the charge. If you don't, and you want to attract these type of people, put this on your job descriptions. If you're not there, guess what? We've seen incredible ROI on just internships. Bringing people in, giving them folks like this, giving college interns an opportunity to take on some of these projects. They do fantastic work. So there's a lot of opportunity here.
Yeah, I think all of that meshes with the constellation of features that you were talking about, right? Think about your architecture as what are the problems you're trying to solve, and how do you find solutions to those problems, not as like a top-down, well, I need an MES, so let me start with an MES.
Yeah. And the next thing here is, we've talked a lot about this, but your most important asset, it's not generative AI, it's not technology, it's really investing in your people and giving your people the right tools. We're not making. It takes a long time to make more people. At least 20 years if we start now, 21 if you count the incubation period. So look, we're not gonna. There's only so many ways to solve this problem, and this is, by the way, core to sort of lean philosophy here. I'm sure everyone is familiar with Taiichi Ohno. who pioneered the Toyota production system. But this is also core to our philosophy back here at Tulip. And the Toyota production system and the basis of lean isn't just about having people work harder or stop thinking and doing what they're told and controlling every action they make. I mean, obviously aspects of that are necessary. You need to follow process and such. But the point here is that you need a more really, how do you achieve results? It's by having a more engaged workforce. And this Toyota production system is built on this foundation that this belief that there's no limit to what people can do in their creativity, and that it's not enough to have people just go to work to do the work they're told to do. Rather, the job is changing, and their job is to think and become active participants in this problem solving. And so this is core to our philosophy at Tulip. If you disagree with this, Tulip's probably not the right tool for you. And this is also how we build the product that we've built. This is a very important slide for me. It's not a cheeky meme, but look, this is, again, this is kind of fundamental to the way that we see work being done. The people who are creating value, really, the people who are doing the work that's resulting in sellable products at the end of the day, is that frontline worker. And the rest of the organization is here to get them the tools they need and help equip them. You've got IT in the back, gassing them up, saying, we've got all your data, we've got what you need. You've got the manufacturing engineer, going to solve the machine that's down or needs the inventory. Quality's checking the tires over there. Those are important. And you've got the head of operations trying to keep everything in order. But this is, I think, pretty well summarizes at least our view of the modern manufacturing environment.
So last up here, we have a suggestion to embrace the open ecosystem, right? As we talked about, we know this space is too big for any one company to go it alone. We know that top-down implementations often fail, and there is a sort of meshing with a bottoms-up approach that we're seeing that ties into what Erik was talking about embracing your people and letting them think and be creative and bring their full selves to the jobs. We know that this is an inherently physical space, that software alone isn't enough, that open ecosystem means an open ecosystem across both software and hardware. And then finally, we have the composability here between different applications as being key to the solution that will give you your constellation of solutions here. Now, as you go into the next year, it's just thinking about how do you embrace this? How do you set up a unified namespace for all of your systems to start to talk together? How do you question vendors to understand their API strategy and how that's fundamental to their technology and their architecture? How do you think about the solutions you need to solve and integrating those solutions together instead of pushing a top-down monolith across everything? And that sort of comes together into where we see the future of this going as an ecosystem of solutions to solve the problems facing frontline operations, not a single monolith coming forward. To wrap up here, just to summarize some of the critical themes that we've talked about today. First up, we have that triple squeeze, the problems that are facing manufacturing across inflation, across supply chain, across worker shortages, and some techniques and tools in order to better engage and attract a workforce that's key to everything you need to do.
Yeah, and the second concept here that, if you remember, just three things. The second thing I think is, in this transition from thinking of MES as an off-the-shelf product that you deploy to this emergent system of capabilities that, get built up based on the operation, based on the needs by the people who are closest to it, either as active participants in the problem solving or as potentially even building these solutions themselves via low-code, no-code capability like Tulip. What you see is this shift to these emergent systems that are solving the problem that MES has been there to address, but in a very, very different way.
Yeah, and that ties into how do you start to move beyond that one system and allow for multiple systems that enable your people to do their job the best and bring their full skill set and mind to the work.
Well, thank you so much, Mason and Erik. We will be getting into Q&A shortly. I just want to call out a few upcoming webinars, along this main topic here. So first, next week, leaders on our customer success team will be taking a deeper dive into that first prediction that Mason and Erik discussed on MES. It's called Breaking the MES Mold, New Strategies for Manufacturing on January 22nd. 5th. We will be sharing resources for you to register. And then in February, we do have a customer webinar featuring Tyco tractors, moving from paper to digital, moving from on-prem to cloud native digital first system. So we'll be sharing some resources for you to join and to put this on your radar. So we are into the Q&A session here. We have a lot of questions that came through. Please continue to share questions as you see fit. So we'll get into this here. So first, when do you think the triple squeeze will stop posing challenges for manufacturers?
Yeah, I can take this one. I think, look, the triple squeeze, it's not a thing so much. It was just like a kind of a moniker that we didn't do it. I think the original language came from Gartner, but it basically said, look, there's a confluence of 3 major macro trends that are all coming together in the context of manufacturing that are going to be massively impactful. And so I think you have to kind of decouple that. What you're seeing is inflation seems to be, let's keep our fingers crossed, mostly under control. The Fed is projecting rate cuts next year. The market is responding. So that's, okay, that's one thing. Supply chain disruption. I think you're still seeing if you think back to a year ago, what was fresh on our minds? Well, COVID was still relatively fresh. It's fresher on our minds. Also, if you think about the Evergreen and all of the supply chain disruptions that resulted due to the issue in the Suez Canal, it exposed the fragility of these supply chains. And what you're seeing is, companies are making strategic investment decisions based on those learnings, which is, they're taking facilities. You're also seeing Congress, with the CHIPS bill, passed. So you're seeing more investment being co-located or reshored. So you're seeing, domestic investment, or if you're in Europe, you're seeing a shortening of the supply chain. Now that's a thing that takes years to completely transform, but it's certainly well under the way. So I think the first 2 are kind of going away. The thing you don't see changing, short of something like massive immigration policy reform, and I don't see Congress moving too quickly on that topic. The workers got to come from somewhere, and that means that and they're there. The people are there, but they don't view manufacturing as the place to go to really push. To be at the cutting edge of technology. And I think that, again, this is starting to change, but it's on us to continue to build the right tools for these people and then attract them with the right kinds of challenges. So, I think the triple squeeze was helpful to think about this a year ago or so. Now it's helpful to think about these as independent things. Labor shortage is going to be, I think, the most pronounced. There will be others. We'll be talking about labor shortage plus generative AI and the lessons learned a year into this next year. So, yeah, that's my
I would add to that, go back to the quote that we had earlier in the deck here around the ability to adapt and change, right? That's maybe one of the things the triple squeeze is teaching us. Of when it ends, where whatever can be debated, but the core theme is, how do you adapt to new change? You don't know what the next thing coming necessarily is. Be responsive, be adaptive, be agile.
Awesome. Great. And the next question is focus on connectivity. Mainly on, is most of the connectivity still on Ethernet and some Wi-Fi, and slowly transitioning to private 5G? Where do you see the combination of that connectivity?
Yeah, great question. I think first, let's separate out internal connectivity from external connectivity. I think the point we were making about 5G and Starlink, things like that, was mostly external connectivity. How do you connect a factory or manufacturing site to the broader internet? And that's where we're seeing more and more places use 5G or Starlink backups in addition to their traditional hardwired fiber line or whatever it is that they get into it. Inside of a factory, private 5G is a really interesting thing that's starting to come around. I think that there's no one solution here. It's if you can wire for Ethernet, right? If that doesn't work, what else are your options? We're also seeing some mesh networks based on radio frequencies. So there's a lot of interesting internal connectivity options arising as well. But in terms of the move to the cloud, mostly it's around that connection to the outside internet.
Awesome. Great. And another question here. What do you think is the most important prediction to consider when evaluating new manufacturing software?
I think the most important consideration when evaluating new software is like one, do they fundamentally believe that like two things? One, that the future is built on an open ecosystem. They're not saying, look, if you buy this, you also need to buy this and this and this and this from us. But do they believe, like, are they going to make their data open and available for other systems to consume, and are they going to accept data from other systems? Because I think that that's really critical. One, two, do they have a human-centric approach? Again, this is one of the biggest challenges here is the labor shortage that we've discussed. But like, are they focused on getting the right tools to your people so they can make the right decisions and be as effective as possible, or are they going to be focused on process adherence, and then it's a thing that the workforce actually just has to live with? And then three, I would say flexibility, agility. This is kind of a at least partially informed by the first two, but there's more fundamental things like is this do they assume a fixed worldview, or do they assume that the world is that it is complex, that it is dynamic, that you will have to continually adapt your solutions based on changing conditions within the system that is the manufacturing operation? So is it designed to be engaged with and iterated upon? Is it a fundamentally agile solution? I think these are probably the three biggest ones that I would pick.
Awesome. Great. Another question here. How do you see the ecosystem enabling connectivity to suppliers and customers to accelerate problem solving within manufacturing?
This is so interesting, actually. We're seeing more and more of this. So some of our, I'll just speak directly for the Tulip customers. Like, we do some work within contract manufacturing, and we see what we'll see is our contract manufacturing customers view Tulip as an opportunity to give visibility to their end customers about how they're running the process and real-time production status and quality checks, et cetera, as an assurance, building the trust between supplier and customer. We're also seeing really interesting things when within some of our enterprise adoptions where customers are they're taking Tulip applications. So I'm thinking of luxury goods manufacturing where they actually they're building like high-end luxury goods. They have a customer or a supplier that's going to take raw materials, gold in this case, and transform it into the form that it needs to be consumed. But they basically say, look, here's what our contract says is acceptable. It could be X, it could be Y. But the difference between X and Y is like many, many hundreds of thousands of dollars a year. So here's a Tulip app that will walk you through how to do this process. We've been measuring the data, and here's what we recommend as a best practice to be able to get it closer to the X versus the Y. So I think that there's a lot of opportunities in these cloud-native open architecture solutions sort of supercharge the possibility here.
Awesome. Another question here. Manufacturing has been using proprietary interfaces. What open standards and architectures are gaining traction?
Great question. I think one of the main things we've seen explode in kind of popularity in the last 1 to 2 years has been unified namespace on top of MQTT. This has been, it's not that new of a concept. It's been around for a couple of years beyond that. But in the past year or two, we're really starting to see it enter like the mainstream consciousness here. Everybody talking about it and thinking about how can we get all of our systems talking together on one protocol in one interface to expose data from this system to that system that connect all of the dots together.
Awesome. Thanks, Mason. Another question here. We have a lot of questions. Besides AI, what other types of new technology do you think will have a major impact in 2024?
This is a bit maybe pedantic, but before there was artificial intelligence, there was just the good old-fashioned intelligence. It's not new, but man, it's a good one. Let's leverage that, eh? Like people, and this goes back to the Taiichi Ohno slide, but I think, it's not a new capability, but I think like leveraging the people who are closest to the problem, who know where to look and oftentimes have really good ideas for how to solve these problems. It's not new breaking, like cutting edge, but the ability to employ that systematically, effectively, capture those best practices and disseminate those best practices across your whole, enterprise, man, that is a game changer. And I think that that's a thing you're going to see a lot more of.
Awesome. One question here. Erik, when you give your 1-minute elevator pitch to a senior leader, what do you say to give their attention, recognizing that most did not grow up with these digital capabilities?
Yeah. Well, it depends on who I'm talking to and, what they say. But I mean, look, on the one hand, like if I want to be a bit provocative, which I sometimes am accused and guilty of doing, I would say like what's happening in your operation right now, and they'll start to answer them. But like, you have no idea. You are blind. There's nowhere you can look to tell me what's going on in your operations. And if you can't see it, guess what? Neither can anyone else in your operation. Unless they're standing there on the shop floor. But like then they can only see whatever they can see. And operations are big and they're complex and they're full of all sorts of interdependent relationships that need to be understood to be able to actually move the needle in terms of output efficiency and cost savings. And then I'll pull up my phone and I'll show them a Tulip application for our operation that we have back here. And I'll say, this is exactly what's happening in my operation. And I'll show them like, by the way, it's not important that I have this information, but because I have it, I know that everyone else who needs it also have it. And then they say, well, wait a minute, what are you looking at? And usually that's one way, perhaps a bit bombastic, but it's one way to start that conversation. Because it's the reality,
Awesome. We have time for a few more questions here. So
great question, by the way. These are all great questions.
Awesome. Given these predictions, what do you think is the very first step manufacturers should take? What will get us transitioning to the composable approach?
Man, I would say demand it. Like, if you have a vendor who doesn't believe this, like at the end of the day, the customers have the power. It's not Tulip. It's not, we're going to respond to the things you demand for us. Everything we've built in the product at Tulip today has been built in response to what our customers need to solve problems and create value. So if just demand this of your vendors, because it's a better future state for you guys. And we need to figure out how to have business models that allow for this best of breed selection. It's this co-opetition, and it presents a lot of challenges for us, but at the end of the day, it creates more value for the end customer, and that should be the guiding principle. So demand it of your vendors.
There's another question here that I think it really ties to, which I love this question. What are some ways to make systems or workspaces more human-centered, in your opinion? And I think that human-centric and composable actually go hand in hand together through all of this, right? That when you have a composable architecture, when you have the ability for people to wire in new parts to fix small problems, you're enabling citizen developers, all of these are really tied together. And one key way to enable your workspace to be more human-centered is to make a step towards that composable approach that enables more people to think about technology as a solution to these problems. And so I think that all, to me, is all this interconnected web of human connectivity, empowerment, things like that as we go into the next year.
Good point.
Definitely. Awesome. And then another question here. Do you think in a regulated industry, what the validation cost is for a composable solution? And is it higher than a COTS solution? Great
question. Yeah, this is a fantastic question. We typically let me take an example of an EDHR implementation that we have going on with sort of a top 10 med device customer of ours. The EDHR set of applications need to be developed to spec. They need to go through all sorts of review, and then once they're deployed, they need to be validated. And we wouldn't expect, and frankly, nobody's going to go through and make changes to those and iterate on them real time, right? That's like, once that's deployed, that needs to be controlled. But now that said, the validation cost is still lower. You can still, rather than having this last 5 years, it can last 6 months or a year, depending on the needs. But more importantly, once you have these applications deployed on the shop floor, they start to capture all sorts of data, like how much time am I spending on different parts of the operation? Like when I'm catching when I'm seeing defects, where's root cause of this defect? Is it upstream or downstream? And we start to get the information that you need to be able to make improvements to that operation that are non-GMP use cases. So the dashboards and the analyses and the actions that are taken as a result of these insights are all non-GMP and can go through this kind of real-time, much more rapid iteration cycle. And they have the opportunity to produce incredible value. So I would say, thinking about the world in these two ways is quite helpful when you're thinking about composable solutions in the context of a regulated environment.
Awesome. We have time for just one more quick question that came through the chat. And any other question that we didn't get to, we'll be able to answer them offline. I know there have been a couple folks that have been looking to learn more about implementing Tulip or implementing Tulip with their customers. So we will definitely follow up offline. Our final question is, how could Tulip, during the pandemic, analytic laboratories were challenged during turning around a PCR or T sample results in a timely manner was challenging for operations too, for staffing critical functions. How could Tulip be applied to enhance laboratory functions during crisis management, risk management circumstances?
Yeah, it's a great question. I think at the end of the day, I would generalize this. It's not just like this is a very specific ask, but generally what the question is like, how can I very quickly and reliably track work across the whole of my operation and know where something is all times and what the next step is? And I think that this is like, I would say that this is within the category of general work order tracking and production visibility and prioritization, right? It's just it's a specific implementation of those concepts. So yeah, if you don't have a system, I think you need one first and foremost. And by the way, that system doesn't have to be Tulip. It certainly could be, but it doesn't have to be. There are many ways you could solve this problem.
I would also say that, in what was it, March 2020, when COVID hit, we saw a number of people start spinning up Tulip use cases overnight in order to help them with labs, help manufacture PPE, that sort of adaptive ability to be, okay, some problem happened. How do I build a solution for it tomorrow was so key across a number of different use cases.
Great point.
Awesome. Well, that was a good way to end this event. Thank you, everyone, for joining us. Thank you so much, Mason and Erik. Really great conversation today, really great insights, and really great participation from the attendees.
Yeah, thanks, everybody. I was also watching the chat. Awesome conversation, and I appreciate you guys having us. Fantastic questions.
Thanks, everyone, for tuning in.
Thanks, everyone, and enjoy the rest of your day.